Some of you got to this part and were at a loss what to do. So as not to do this for you, because this is still a lab and you are showing your understanding, and I would like for you to use the knowledge and the practice and the algorithm and the steps that are the same through all of these examples that we covered. Use the same steps with these new numbers. It's the same over and over. You are looking at a projectile shot at a given velocity, and direction is given in the degrees to the horizontal. You are asked to find the vertical range and the horizontal range, as in how far is it going to travel horizontally and land on the ground? How far is it going to travel vertically? What is the highest possible point? Maximum height, in other words. So I'm going to solve another example for you. And I'm going to show you again in that table that we used during our Monday. We looked at how these types of problems are solved. So here goes an example. If we have an air toy rocket launched at initial speed of 53 meters per second at 30 degrees to the horizontal, find horizontal and vertical ranges of the rocket. If the rocket is shot at 30 degrees and the speed is 53 meters per second, then the first thing before you do anything else, just like in the laminate, you're going to find your two separate, very, very different components of velocity. So if this is 30 degrees right here, this is Vx and this is Vy initial. Vx is going to be found using cosine. So it's going to be 53 cosine of 30 degrees. Vertical initial velocity vertically will be found through sine, so it's going to be 53 sine of 30 degrees. So if you use a calculator, so the reason why we separate it is because horizontally our projectile will not have any kind of acceleration, and so when we're looking for the horizontal range, which is delta x, we need to know the time, and we will multiply Vx times time. Now I have a place right here for change in time. Horizontally, I cannot find time. There's nothing that would allow me to use this formula, and that is the only formula that works horizontally. I do not know x. I know Vx, but I do not know delta x. I'm looking for it as a matter of fact. So I do need to find time. Now, how do I find time? Remember when we had projectiles launched horizontally, we used change in y equals 1/2 gt squared. Well, that was convenient, right? As soon as they give us y, we can just plug it into that formula and boom, we can do it. Not here, because here your initial velocity is not 0, so that formula will not work. I cannot use the full formula either. V initial change in t plus 1/2 acceleration t squared. I don't know what my change in y is, so I cannot use this formula. There is a number of other formulas in which time is involved, but I don't know V final. So in this case, my only option is to realize that at the top, Vy at the top, and this is in your laminate, is 0. So how long does it take to get there? I can figure it out. Since I know my g and I know my change in t can be found by replacing it in this formula. So therefore, change in t is going to be 0 minus 26.5. Mind you, I'm not using 53 meters per second. Even though they told me that the speed is 53 meters per second, that is not horizontal or vertical. We had to split it into horizontal and vertical part is only 26.5. So that's what I'm going to use. 0 minus 26.5 over negative 9.81. So change in time is 2.7 seconds. But that is half time because it takes half of the time to get to the top. And then the other half time is going to be to fall back down. So the total time is actually 5.4 seconds. Now I do know the time, and since I do know the full time, I can now go over here and plug it into the horizontal part. So I can find change in x equals Vx, which is 45. Again, very important, you do not use 53, you do not use 26.5. You use the one that is horizontal, times 5.4. That is 248 meters. Vertically, you have options again. You can do change in y equals V initial plus V final over 2. So 0 plus 26.5 over 2 times time. times, and you use half the time, times 2.7. That gets me 36 meters. Then I can use change in y equals v initial time plus 1/2 gt squared. Again, you're using half the time. 26.5 times 2.7 minus 9.81 over 2 times 2.7 squared. Voila, 36 meters. And then finally, you can use v final squared equals v initial squared plus 2 g delta y. Delta y is going to be 0 minus v initial squared over 2g. So 0 minus 26.5 squared over 2 times negative 9.81, 36 meters again. So this is an example of how you would solve for horizontal and vertical range of a rocket that was shot at 53 meters per second and the degree to the ground is 30. You are supposed to solve for a different and twice for the same rocket that is shot at 75 meters per second, and you are given two different angles, 60 and 30. Just remember, so you save yourselves time, that sine of 30 is the same as cosine of 60. So just like in the example in the lab itself, in that example, your x and y components for shooting at 30 and x and y components of shooting at 60 are just going to be interchangeable. So once you find your x and y components of velocity for 30 degrees, just switch them for 60, or vice versa, whichever you happen to start with.